Hey guys, welcome back to the channel. I have another Marine ECM here on the lab. This is from Evan Howells. He sent his computer. He opened it up and it damaged a component in the pads that are there. It was very hard to repair. Luckily for him, I was able to actually fix it. And the funny thing is, probably you will have already seen. I have a computer from another customer, Anthony Estavia, and these two computers have the same date. So look at this. 07/24/2000 is their PCM B0101. This is a 225 DF5. Let me just put this on here. And this one is a 496 MAG HO, but look at the coincidence. I mean, I'm trying to get as close as I can. The computer is powered up, so I don't want to. Oops, sorry guys. Drop my phone in there. And I want to show you that, yeah, it's a PCMBE0101 from the exactly same date. I mean, it's like finding a needle in a haystack, right? But well, all right, going back into this computer. So he contacted me on the chat onto my website. He said, I have a Motorola PCM B0101 that needs some repairs and it needs to be tested. I opened the picture, which I'm going to show you in a second. I said, it seems now that the PCM was open and some internal components and pads are damaged. So I will have to access the damage and see if it can be repaired or not. So let me go over to his folder, which I have created here, and you will see the damage closer. So as you can see, this is a component, and it's hard to say or see because of the picture he took, but you can see how these pads or legs are completely ripped off from the board and it's still holding in here. But the problem is under here, let me see if my pictures, you will see that, yeah. So under here, and I put markers of where, those paths are going and everything, because this has connections on top, but under here we got 4 more layers, and you can see this lines in here, those go through under it, and it got ripped out completely. So very hard to repair something like this. Although, sorry about that, I'm gonna have to probably, well, I don't think there's any information in there that I need to cover, but this is all I could do. So yes, you have to create pads, solder, and I put, solder mask, cement, so that's not going to, corrode or anything, and then run the pads externally because there is impossible to fix that any other way, right? So it doesn't look pretty. If it would be a short distance, I have a repair kit that mimics or it has the same layers that you see there, but these boards are it's like a composite plastic clear that they print, and now you can solder, the components. It's pretty good. But so I would recommend you if you have a problem on one of these computers, please do not open it because that might at the end create a not repairable computer, which was almost the case with his. I'm going to just show you that indeed that is the repair right there. So this is for Evan Howells. So Howells is a little difficult for me to find out exactly how to say, but yeah, so the repair is done. I want also to address and show him because what did damage the computer, not what he created. I already repaired as well, and now the computer is communicating because the computer wasn't talking or it was a completely dead computer. And I have it already connected. Everything is ready to go and run the computer, which, yeah, I think it might be okay in there. I have to change actually the signal that I supplied to this, so give me just 1 second. This is for my simulator, so you will not need this because you will not be able to use it. So let me write that in. So I'm writing that signal into my simulator, so it's ready to run. But so what I left, because when I connect this, I don't know, temperatures or anything. So, but I don't want to change this to show you that the starboard exhaust cool temperature is in 206, which is, I mean, overheating, right? And my coolant temperature is in 64 and the air temperature in 4640. The reason I leave that in there is because when I read the history, and I don't want to change that yet, but yeah, when I read the history for faults, I go first by hours. So we have 36622, right? But then I also see what the temperatures are. Okay, coolant 6440, that's mine. So I can disregard that one. 6440, I can disregard that one. 6440, and you see their temperature right there the same. So I can disregard that one. This one is his. So we can see right here the coolant temperature in 168 and the manifold air temperature in 116. The engine running at 4700 RPMs in the Guardian mode. Battery voltage at that RPM is in 1319, which a little low for such a high RPM. I'm going up. This is another one that is his, and this is what I damaged the computer. Very common on these computers. As I mentioned, into Anthony's the other computer that I repair. Battery voltage low. We have the engine running in idle, 755 RPMs, but look at the battery voltage, 10.17, and it's running. So yes, when the engine was cranking, that voltage probably went down to 4 volts. That corrupts and damages the internals software and so on the computer. So yes, when this computer gets here, I had to reload the calibration, replace a EEPROM and the components of the firewall references, and I do a full repair because my repairs has warranty. So I'm not just going to correct your issue, I'm also going to repair the computer, right? But yeah, so now all this done, and this is how I know which are his faults and which are my faults, as created here. Main power relay 7520, 7520. And look at this one. This is a perfect one. I didn't see this before. Look at this. After the engine is stalled, look at the battery voltage. 5 volts. No, 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 no. That is immediately red flag. And if I repair a computer, which I'm going to erase the history, and let me just make sure I do that. Make sure that I have already the history, and yes, I do. You see, I always say that for my files. So I have all the history in there. And one other thing that I do, let me close all this, is I go over to the tests, and you can do this in here, and I go over to system information. This is going to tell me if the calibration of the boat that is installed is the correct one back, right? Because I just installed it too, right? So want to make sure that that calibration is fine. But yeah, we have X636194, and that is exactly the same calibration that we have here. So that is perfect. So I always copy this and I go over to my folder that I have for him, open the PDF folder, and then add a text right here, and I add that. So I have always to make sure that everything is recorded so there is no misunderstandings later. The other thing that I also check is the engine location, if it's port, starboard, or port 2 or starboard 2, depends if this is a multiple engine boat. This is on a starboard, so I always put a mark on the board on here telling what position this computer is set to. All right, so but yeah, let's go back to the run. I definitely going to change now the temperatures. I'm going to go over to starboard, which is in 200, and I want to bring down. I usually keep it in 100 and 120 or so. I'm going to change the port to around the same, so both manifold temperatures are reading the same. I'm going to change the coolant temperature, and this is also on purpose, again, to make sure that logic in the computer is able to read and work properly, like as far as reading sensor values and all those stuff. So I like to keep it around 160. The coolant manifold temperature for me is not that important, but we can raise that to 70 degrees if we want to, um, or 100 degrees, right? So anywhere around after that is fine. The oil pressure is a little low, so I'm going to raise that oil pressure to around 20, so we get the 100% of power when the engine is running. I like to keep this 8.1496 around 6.1 psi for cranking. So everything is ready to go, and we got IX do the cycle, and you will see if the IX is good. You will see this test light coming on. So let's run in, and it's running perfectly. So we got 1100 RPM. Let me bring that a little lower to idle around 650, 700 RPMs. But we have the computer running with 100% power. The IAC is just dim, but it's there, and it's okay because that's what the computer is commanding. You see, the IAC is at 5%. So um, I'm going to just select so you can see where I am looking at. You see that now dotted line. I can put my red signal in there, but you see, IAC do the cycle, so that's fine. 5%. That's what the computer is calling. That's what the calibration is calling. That's good. All right. So the other thing that I like to do when I repair a computer is open my oscilloscope to see CAN buzz and so on. So am I gonna have to set that up? Let me see if save the last settings. Otherwise, I'm gonna have to reset I'm gonna have to reset it. Give me 1 second. All right, guys, I'm gonna have to. Well, I have the scanner connected. As you see, have oh, not the scanner, the oscilloscope. Sorry. Blue channel is CAN bus, red channel is injector voltage, as it says in there, gray channel EST, which is the coils, right? One of the coils, and yellow channel, the tag. We got all the signals, but no CAN bus. Even though the computer is running good, the way that, or the reason this computer has a CAN bus in there, let me change the leg temperature because it's too high. Well, that's not going to make any difference, but yeah, the COM buses for smart gauges and some other things that are not going to be working if I cannot repair that. And I'm a little worried about this damage that he did because I was able to repair as much as possible the computer, as you can see there. But yeah, some of the signals that this device that he pulled out are taken in consideration is for that, for the COM bus. So I'm going to have to poke more. And yeah, he damaged all other communications from the EEPROM to another component in here, as you can see here. So, but yeah, I was able to reestablish the computer from running, but it might have a problem with the COM bus. And yeah, I would say I'm going to try to do my best to repair 100%. The computer, again, is running good. I'm going to raise RPMs, so let's do that. Let's go up to 4,000 RPMs. I'm going to change the throttle position accordingly, around 40% or so. Let's raise the map values. And we can see, all the injectors are perfectly working. I have no difference or no problems. TAC and all the rest of the signals are there. So if the computer is running good, reason of the 90% is probably or most likely a knock sensor. I do have two coils unplugged, and I do that for my own purpose. And one thing that I want to show you is now the duty cycle on the IAC is 99%, and we can see that on the test light. So now we had a nice and bright, so that is all working good. The computer to run the boot will be working 100%. If he doesn't have smart gauges, I can disregard this repair as far as the COM bus, but if he does have smart gauges, that will be a problem. So I'm going to stop the video here, see if I can poke a little more and try to repair that section, and otherwise I'm going to have to contact him. All right, guys, I'm going to stop the video and I'll be right back. All right, guys, I got the computer back connected and working 100%. We have CAN bus, injectors, EST, and tachometer, 100% power. Again, I want to, oh, and also I forgot, I think, to show in the beginning the firewall reference on this computer. And just so you all can see that it's indeed the same computer that we were working before. I'm going to lift it in here so we can see that repair in there. But yep, it's now working 100%. The reason we see just the blue bar there is obviously because I'm in 20 milliseconds. That is a too slow of a capture for a CAN bus that is super fast. But if I slow down, the reason I do that is because otherwise we will not be able to see the rest of the signals. But yeah, we can see the CAN bus in there, and the reason is that is because I don't have a terminating resistor in there, but I know that is working as long as it goes from 2.5 to 1.5. That's what I'm looking for, and I know it's working 100%. All right, guys, so this is definitely 100% repair computer. Now it's working as it's supposed to. I'm going to have this computer running probably an hour or so to make sure no hiccups or anything. But yeah, based on the history that I have, that we all see before this was created, his concern, his problem, his real problem on the boat is charging system and battery. So you need to check your charging system. Make sure that you have, if you have a boat and your battery is dead, don't try to crank it with a battery. Remove the battery from the boat, charge it, fully charge it, then put them in the boat. If you still have a low crank, clean the engine grounds. Make sure the starter, the engine to battery ground is super clean because otherwise that starter is going to start to draw a lot of amperage. It's going to drop the voltage and it's going to corrupt calibrations and it's going to be costly. Faster and very cheap, just charge your battery. If you have a bad alternator, replace the alternator because if the computer gets damaged, you will still have to replace the alternator. Otherwise, every time you connect your computer, yeah, your computer and you're trying to run the boat, you're going to damage the computer very shortly because right now we have new components, everything is working good, new calibration, everything will be working good. But you know, 4 hours, 5 hours of that battery voltage cranking low and stuff like that, it will damage the computer again, and that will not be covered under warranty. All right, but Evan, your computer is now working and fixed 100%. I will contact you shortly to collect payment and send this your way as soon as possible. Thank you so much, guys. Don't forget to subscribe. See you next time. Bye bye.